We'll go from current slide. I'll even turn on the projector today. Okay. Now this one announcement, they sent it out late, 9:21 Tuesday evening. So I know I didn't report it. They have finally opened the student course evaluations for first mini-term courses, or any of you in a first mini-term course. Okay. You know about the student course evaluations? Okay, good deal. Seems like a lot of the students that I've talked with have known it. If you know of anyone who's in a first mini-term course, especially if they tend maybe not to keep up with email too rigorously, you might tell them the student course evaluations are open. So they open them up about 9 something, and then let me know that none of my students had responded yet, okay, because they just opened them. So I thought that was very kind of good. Okay, that's the school-wide announcement. Let's get on my personal type announcements, okay? My here is here. That's the page here. There we have it. First, I will not be on campus tomorrow. I will not be on Birmingham West campus or any campus. We got a trip out of town. I'll be on the road by the time I would be at campus at 8 in the morning. So I've been on the road for a couple of hours probably. Okay, so that's tomorrow morning. Right? Okay. So that's tomorrow. I will not be on campus at all tomorrow. Normal office hours would have been 8 to 12. Birmingham West campus will not be there. Okay. The next week is the terrible week. Okay. Tuesday morning I have a doctor's appointment, but I will be here from 8 to 8:30. Then we'll be in class from 8:30 until about 9. At 9 I've got to leave and head to the Kirkland Clinic for blood work before my appointment at 10:20. So I have to be there by 10:40. Have to be there by 9:40. So, very short class. Now, one way we can make it a little longer, can any of you be here before 8:30? Because I'll be here at 8. No?
I'm just got to bed at 8 o'clock.
What's that?
I'm just got to bed at 8 o'clock.
Hey. All right. Well, I'll be here as early as I can be, and when people start showing up, we'll get going. It'll all be recorded. Okay. Now, that's Tuesday. All right. Remind me, Alexis. Yeah. Second? Yeah, I'll be here at regular start time. Just got time, Alexis. I know you're in here. Don't be hiding. There you are. Good deal. Anyone else come in and says call roll that I did not acknowledge your name? Okay. That's Tuesday. Doctor's appointment. Sorry. And I'll also at that time on Tuesday morning tell you where to look to wrap up whatever we're working on that day in the YouTube videos. Because I have them all out there. I'll just point out to you where that is. Okay. Thursday of next week, I'll be in Tuscaloosa at a professional conference there. I wish they hadn't put me down for a Thursday, but they did. Unfortunately, they didn't have any good days. Friday is the logical day for me to have those conferences. They don't have any on Friday, so I was going to have to miss some classes, but I hate that I'm missing Thursday again, especially in the same week I just missed part of Tuesday. But Dr. Thomas will be here, and she will be giving the test. So come prepared for your test. I've already told her you can have formula and equation sheet, scratch paper, calculator, graph paper if you prefer to use your own. I'll have graph paper. If you don't bring some, I'll have graph paper you can use. Okay? It's a pretty long test, so please get here early, get started on it. Now, that leads to another issue. Remember, you can't take the test until you turn in the quiz, or you ask me to give you a 0 on the quiz. Now, since I won't be here for you to ask, I'll assume if you take the test without the quiz, you want a 0 on the quiz. So, right now I have 1, 2, 3, 4, 5, 6 people who have not turned in quiz 1. So I would say, get it into me today. I will not be on campus tomorrow. Get it to me on Monday. I will be on campus Monday. Or get it to me Tuesday morning. Okay? I will be here until 9. Or Tuesday afternoon. I'll be back sometime after 12 for my doctor's appointment. Or get it to me on Wednesday. But get me your quiz before test day. Because Dr. Thomas won't know whether you turn in the quiz or not. If she gives you the test, you take the test without the quiz, that means you get a 0 on the quiz. Okay, please turn in the quiz. Sooner rather than later so I can get them back to you. Since I don't have them all in, I can't return them to you, but you can always come and see what you scored on your quiz. Come today after class. Monday, I have office hours 8 to 10 and basically 3:45 to 6. Tuesday, I have office hours 8 to 8:30. Okay, I will be here then. And Wednesday, I have office hours 8 to 10 again. So there's plenty of time for you to come and look at your quiz, see what you missed. As soon as I get the last one in, you'll get them back. Okay, as soon as next time we meet. And if they're all in by Tuesday morning, then Dr. Thomas, I'll leave them with her and she'll return them to you. Get them to me before then so I can return them to you Tuesday. That would be preferable. All right. Any questions? Okay, let's see. Is that everything? Friday of next week, I'll be on Birmingham West Campus from as close to 8 to 12 as I can. I do have a dermatology appointment in the afternoon, but I don't remember what time in the afternoon. I think it's late enough that I won't have to leave early, but at worst, I'll have to leave a few minutes early to get to the appointment on time. I just don't remember what time that was. It happens once a year, and I just don't remember when they schedule it. My wife has it all. I don't. Okay. All right. Any questions? Okay. We're in Chapter 1, Functions in the Graphs. Last day here in Section 1.9, the last section we're going to cover, inverse functions. And I'm trying to recall I believe we started on example 6 and got most of the way through example 6, but didn't quite get to the PowerPoint. Okay? Is that what you remember? I have another mark on the page at example 7, but I forgot to erase one of my marks. Where were we? Does anyone recall? Were we still on 6? Say again? You think so? Okay. And if you see from here, remember, now this is not example 6. Remember, they had the wrong example. The example 6 that's in your text and that they're doing down here. Well, here it is. Okay. It's not this, it's this right here. This is example 6. And remember we did the vertical asymptote, even though we haven't talked about this yet. That's where your denominator would be 0. So you know that can never be 0. So this is minus 2/3. So x equal minus 2/3 is your vertical asymptote. These lines approach it but never can touch it. Okay? Then your horizontal asymptote with the ratio of the leading terms. Negative x over 3x, that would be negative 1/3. And that's your horizontal asymptote at negative 1/3. Now these could touch them, they don't, but they do approach it, the negative 1/3. Okay? We did the graph already. Then we had our intercepts The x-intercept is where y is equal to 0. That only occurs where the numerator is equal to 0. And that would be x equal 5. Okay. Yeah, x equal 5 right there. Okay, 5, 0 is your x-intercept. Looks like it's awfully close there, but it's not, doesn't actually intercept except at x equals 5. The y-intercept is where x is equal to 0, and that would be at 5 halves. 2.5, here's 1, 2.5, so right there. I don't know particularly why they have a point here, but it's not. There's the y-intercept right there at 2.5. Now, with the vertical asymptote and the horizontal asymptote, I think I'll draw those in. They did a disservice here by drawing their horizontal line showing it is a one-to-one function, but I'm going to draw in the vertical asymptote is at, what do we say, minus 2/3. Okay, horizontal asymptote was at minus 1/3. Okay, so we had this point, 5, 0. Ooh, that I meant to be dark. Okay, 5, 0, and 0, 2.5. Okay, those are our two intercepts. So that defined this curve here, those 2 points. They only needed one, they had 2. We didn't have any points here, so I think we evaluated it at -1 and wound up somewhere way down south there. And that told us we were in that quadrant down there. Okay? Now, that gives us the graph. The purpose of the graph is to determine if it's a one-to-one function. The question, is it? Why not? Okay, so a little louder, stuff out the horizontal line. I got that part.
I said the horizontal line.
How? Why not? Here it crosses once. All the way up it crosses once. Down here, believe it or not, it only crosses once. Even though this is getting awfully close to horizontal, still only has each value once. Over here, this is awfully close to horizontal, but it's not. It only crosses once, and certainly down here they only cross once. So it does pass the horizontal line. Now, this is where my earlier statement has a little bit of an issue. This is a strictly decreasing function, except for where it's not defined. Okay, it's not defined at x equal -2/3. Of course, there is no value there, but anything past that is strictly decreasing. Okay, so yeah, this function does have passed the vertical line test. I mean horizontal line test, which means it's what kind of function? Say again? One-to-one function. Y'all are good. Okay, a one-to-one function, which means it does or doesn't have an inverse. It does have an inverse. Oh boy. Okay. So we've done step 1. All that was step 1 to see if it's a one-to-one function. It is. What's the next step? Anybody? I'm going to write it here because that's awfully small down here. 5 minus x over 3x plus 2. Okay? What's the next step? Exactly. Really simple thing to do. Instead of f of x, call this y. Very simple thing to do. Boy, that first step took a while. Okay? Second step, really easy. You set the f of x equal y. Next step. Interchange the x and y. So that becomes what? X equal 5 minus y over 3 what? 3y plus 2. Didn't we do this? We did it on one. I don't remember. Did we do it on this one? Wait, say again. Okay. Let's fix it, right? Yeah, we did. Okay. What we hadn't done was look at the graph here. So you remember yeah. Because remember we had to multiply both sides by 3x plus 2 and then isolate the y's, get them on one side, get the things without y's on the other side. So we've done all that, okay? So let's see how they did it. That's where we were, okay? So they go back, pass the horizontal line test. You know it's 1 to 1. Here's the function. They wrote it again. Good for them. And then they were listening to what Tucker said, and they set the f of x equal y. And then they listened to what whoever said, exchange the x and the y. That's just what I had written down. Now, what's the next step? Okay. Yeah, the whole purpose is to solve for y. Okay? So what we do is multiply. Get rid of that denominator. I mean, y'all make laser fractions, but I don't care for them that much. So get rid of the denominator, multiply both sides by 3y plus 2, and that gives us x times 3y plus 2 is equal to 5 minus x. Now, our whole purpose here is to solve for y. So what's the next thing we do? Yeah, get rid of those parentheses. Distribute here. And what would that give us? 3xy plus 2x is equal to that. And sure enough, that's what they did. Next. Remember, we're trying to solve for y. Okay, we want all the y terms on one side and all the non-y terms on the other side so we can solve for y. So that means adding y here, subtracting 2x there. Got it? J is here. Okay. Now, and that's what they did. Good for them. Added the y here, get y's over here, subtracting 2x, so to get all the non-y's on that side. Okay? Now what? Okay, what is it? Okay. He's going to take out the y. I hope he's not a gangster in that sense of taking it out. Okay. No, we're going to leave it alive. Okay, yeah. We're going to factor out the y, leaving whatever is else. Okay? So let's see how that does for us. Y times 3x plus 1 is equal to this. And what do we do now? We get the guy. We're wanting to solve for y. So I can get a little up. Subtract? Is that a addition sign in there? Divide, yeah, because that means multiplication. You undo multiplication by dividing. You have to get back to your fractions, but this is almost the last step, so we don't mind it too much there. So we divide both sides by 3x plus 1. There we have our y is equal to 5 minus 2x over 3x plus 1. Next. Really simple step. Say again? Not yet. One more little step. It's a minor one. It's and remember? What does this become? F inverse, exactly. We changed our y now not back to f, but to f inverse because we did the inverse operations. So now we made an f inverse. Now we do our checking steps. Okay? And guess what they say? Check the f inverse, f of f inverse is equal to x, and f inverse of f is equal to x. They don't tell you how to do it. Okay, so this is typical textbook. They say, do it. Okay? That can be some of the longer steps. But anyway, that's what they got. Now, that is the last slide in the section. What's that? Yeah, we did this. Yeah, we did both of them, in fact, didn't we? Or did I say you can do the second? Okay, yeah, I think we ran out of time. Okay, but they also didn't do example. Any questions on this one? Okay, there is a checkpoint, and those checkpoints are really good to do shortly after you get out of class while it's fresh on your mind. If you do get stumped, do you sit there and fret? No, you go to larsonprecalculus.com and see audio video solution right there. If you get stumped during the checkpoints, you can check it out. What's that? It's in your book, larsonprecalculus.com. Larson's the author, Precalculus is the name of the text.com. Okay. Now, any questions on this for delete? Okay. So I'm going to go back up here and do example 7. All right. Huh? Yeah, anyway, that's what I was going to say. All right. So we're just missing Jalen, right? Drake and Cordarian. Oh, there we are. And Trinity, but we may have lost Trinity, I don't know. And then the bottom part of the alphabet fell apart. Cameron, Diego, Jamel, and Jeff. Okay. All right. So let's do example 7. Find the inverse of this function. F of x is equal to the square root of 2x minus 3. Okay? Now, what's your first step? Second? Okay, yeah, you're jumping ahead. What's the first thing you ought to do? Otherwise, you could spend a lot of time working and get a... You have to what? I hear someone say something, but I can't make it out. Say again? Not quite that. What you want to do is see if it's 1-to-1. How do we do that? And I think you said it. What did you just say? Graph it. Unfortunately, I think I could talk my way through it, but you probably want to graph it, so let's graph it. Okay, now, before we even start the graph, when you see a function like this, bells should go off, warning signs, flags should wave. Why? Yeah, you have a limited domain here. What can you not have? Inside a square root, what can you never do? Take the square root of a negative number. So how will we begin here? We'll say that what's under that radical, 2x minus 3, has to be what? Greater than or equal to what? 0. It can't be negative. It's got to be greater than or equal to 0. Okay? Has to be on the positive side of things. So let's solve that inequality and see what we get. What do we do? Here, add. Say yes, somebody. Yeah. All right. Okay, add what? 3 to both sides. Okay. And that gives us 2x is greater than or equal to 3. And then divide by 2. And that gives us x greater than or equal to 3/2. So, if I'm going to graph this, I'm going to put my y-axis way over here because I know that I'm not going to have any negative x's. In fact, I'm not even going to have an x of 1 because x has to be greater than or equal to 3/2. The other thing I note is this is a, oh, by the way, what's alpha of x? Y, okay? And what is this? Square root sign. That means principal square root, meaning positive square root. So therefore the y is going to be greater than 0. So I'll put my x-axis down here, okay? That helps me say where to begin. And we know we got to start at 3/2, so we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4, 5, 6, 7. We can go on if we need to. I don't think we'll need to. So 3/2 is 1 1/2. That's where we began. Well, let's see if we begin there. When x equals 3/2, this thing is equal to x equals 3/2. 2 times 3/2 would be 3. 3 minus 3 is 0, and square root of 0 is 0. So there's our first point. All right. Now, how would you get more points? By getting all your answers right? No, that's a different kind of point. Okay. I'm really lazy. So I'm not going to just plug in x equal. I know you can't do x equals 0 or 1 because you have to start here. I'm not even going to do 2. Okay? Well, yes, I am going to do 2. Why? What would 2 give us? Say again? 2 times 2 is? Yes, that'll give us 1. Square root of 1 is? 1. Okay. So at 2, we're up here at 1. Okay? I will do 2. But I'm not going to do 3 because 3 would give me 6 minus 3 square root of 3. I don't know what square root of 3 is. And I've got a calculator and can do that just fine. But see, I'm really lazy. I want to only pick values for x that give me something I already know. So if what's under here is a perfect square, like 4, then we can do that. So let's say 2x minus 3 equal 4. What would that give us? Solve that equation. Add 3 to both sides. That gives us 2x equal 7. X equal 7 over 2. That's 3.5. So up here at 1, 2, 3.5, we are at 2 because the square root of 4 is 2, right? I can do that in my head, okay? Do a little bit of work out front, okay? What's the next perfect square? We did 1 and 4. We did 0, 1, and 4. What's another perfect square? 9, okay? 2x minus 3 equal 9. See, if I have a 9 in there, I know what the square root of 9 is. What would that do for me? Add 3 to both sides, and you get 2x equal 12. Divide by 2, and you get x equals 6. Okay? So 1, 2, 3, 4, 5, 6. X equals 6. That will be 3, because the square root of 9 is 3. Want to try one more? What's the next perfect square? 16. 2x minus 3 equals 16. Add 3 to both sides. That gives you 19. 2x is equal to 19. Divide by 2. And you get x equal, what's 19? Halves. Second? 19 halves. 9.5, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9.5. Right there. We can do that one. And that would be a 16 here. Square root of 16 is 4. So there we have it. Here is our graph. What's the question we ask ourselves? Or what's the test we run on that graph? The what? Horizontal line test. Does it pass or fail? It passes, right? Every horizontal line only intersects one, right? So we do know we have a one-to-one function. It does have an inverse. All this was just to determine that. Say again? Was there a question? Okay. I thought I heard a terrible groan. Okay. All right. So let's erase all this, because all that was just to get the first step done. Is it one-to-one? And we answered resoundingly yes. Now, did we have to do all that? Hopefully not, because if you remember what a square root function always is, half of a sleeping parabola. And half of a sleeping parabola is always one-to-one. Okay? So we didn't have to, but I knew y'all wanted the practice of doing that. Was I right? Say yes. Okay. All right. What's the next step? Say again? Replace the f of x with y. Y is equal to the square root of 2x minus 3. I just want to remind you, x here is greater than 3 halves, and we said that the y, which is your f of x, is greater than or equal to 0. We had that from the graph, but I erased the graph. I just wanted to remind you, those are what we got. Okay? Now, what's the next step? Okay? And what would that be then? X is equal to the square root of 2y minus 3. All right, good. We're moving through the steps now. That first one took a while. Okay, what's the next one? Solve for y. Ooh, what's the first thing you got to get rid of to solve for y? The square root sign. How do we undo a square root? Square both sides. And that gives us x squared is equal to 2y minus 3. Okay, y'all are good. Now, warning, warning, anytime you square both sides of an equation, you may be introducing what they call extraneous roots. So we have to, at the end, go back and check and see if we didn't introduce something we really don't want to be there, okay? And that's why I put these up here, because that's going to help us know that. All right, next. Wanting to solve for y, so what will we do next? Help me. Add 3 to both sides. Okay, and that gives me x squared plus 3 is equal to 2y, and then one more step. Well, one more in solving for y. Divide both sides by 2. Okay? Ding, ding, those go out. So we got our y. Y is equal to x squared plus 3 divided by 2. Now what do we do? Pretty easy step. Say again? You may be right, I just didn't understand. That's it. So this becomes your F inverse, okay? So it's a simple step. It's easy to forget you're supposed to do it. Get it out of there, okay? Is equal to x squared plus 3 over 2. Now, it said find the inverse. We did, okay? Now, what we are supposed to do next is what? Verify. Okay. You want to do it? Just for practice, because you may have to do it on the test, you know. You want to do it? You want to review how to do that? Huh? Okay. I don't say that it is, huh? Say this again. Yeah, we're checking to see if that is indeed the inverse. How do we check that? It's called verify. This is a skip, the step, the book skipped last time. I can't talk. F of F inverse of x, and see what that is. What do we do first? Put the F inverse in, leave the F alone for now, and put in what F inverse. Well, there it is, right above here. That's x squared plus 3 over 2. Now, the F function, this one right up here, operates on that. Whatever is inside the parentheses here, it puts right there. So what do we do? What is our F function? The square root of 2 times x squared plus 3 over 2, and then you subtract 3. Okay, so let's do what it says. What you reckon we're going to do first? Yeah, divide out the 2. You know, yeah, he's what was that first one? wasn't bump off, but it was something like that. Get rid of the y, okay? Now he's getting rid of the 2's, okay? He's pretty, okay, never mind. All right, so that's going to be the square root of x squared plus 3 minus 3. And what does that show you? Plus 3 minus 3 is 0, 2. Get rid of them, too, okay? And that's the square root of x squared is the square root of x squared. What's the square root of x squared? X! You're absolutely right. That is exactly what it was supposed to be. Now, technically, we're supposed to do it the other way. You know how to do that now, don't you? Because we've done it this way. Now, here's the other thing you could do. I sort of regret that I erased it now, but I'm okay with it because I needed the room. What we're also going to do is graph these two. Okay? Now, I'm going to erase most of this stuff, so I'll have room to graph and you can read it. Is it okay to erase? Now remember to verify, you need to do it both ways. We just did it one way just to save time. Okay? But we're going to erase all this. I'm going to leave my function there. Well, I hoped it was going to erase. Okay. And we'll... Oh, I just erased the inverse function. Sorry. But y'all can tell me what it is, can't you? Well, since I erased most of it, I'll erase the rest of it. Okay, remind me what the inverse function was. F inverse of x was, say again? A little louder. The square root of, no it wasn't, that's the function. Wasn't the inverse function it was 2x squared. That's it. X squared, what's that? Plus 3 over 2. Right. That's what our inverse function was. So what we're going to do now is graph these two. Okay? Now again, we're going to set up our graph where we had it before. The y-axis way over here, it should be straighter than that. The x-axis down here, that's not bad, but okay. Let's tick off a few points if I can. No, I can't. Okay. 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 Now, but remember this. For our function, x had to be greater than or equal to root 3 over 2. I mean 3 over 2, which is 1.5. And y had to be greater than 0. That means for the inverse function, you reverse those two. Now your x has to be greater than or equal to 0, and your y greater than or equal to 3/2. You see, remember we exchanged the x and y. That was one of our steps. So we also exchange our limits there. That's why it's safe for me to do the graph like this. Now we already did this one. This had a 0 here. I can't get it to write. Get out of there. I can't get my pen to write. My thing's gone crazy. Let me try this. Where's it going? Okay. All right. I'm going to cancel that. Yeah. Nope, still doing it. Go back and do it again. Sorry about this. I drew my x-axis too near the bottom, and it just screws things up down there. Okay. Now, I thought I would cancel that. This thing's just going nuts. Okay. No, it's still doing it. It's not responding. It's Microsoft problem. It's not the Screencast-O-Matic. Okay, sorry folks. That's not doing anything. I need a marker. I'm going to go steal one from next door. I'll get it back in a minute. Technology fails, we'll go to regular. Okay, remember our first was at 3 halves 0, right there. And then when we went to 1, we were 1. Remember we did? And then I think when we were 5 halves, was that right? No, 7 halves. We were up here at 2, remember? And then when we were at did anyone keep your graph? What was that point? Next one. We had here, here, 6. 1, 2, 3, 4, 5, 6. We were up here at 4. At 3. Oh, 3. 1, 2, 3. Okay, and then we were 9.5. 7, 8, 9.5. We were up here at 4. Somewhere. Okay, so this was our half a sleeping parabola, remember? That was our F function. This is alphabet. We could have brought 2 markers of different colors, but I only stole 1. But, okay, let's do the F inverse. Okay? Now, what function is that? I'm going to rewrite it slightly like this. 1/2 of x squared, that's this part, plus 3 halves. Now that makes it a little easier to plot. That's easier to see. This makes it easier to plot because when x is equal to 0, this is at 3 halves. 1, 1.5 is right there. Okay? Now, when x is equal to, now I'm just going to plug in. When x equals 1, I'm not going to use 1. Let's use 2. Okay? When x equals 2, 2 squared is 4. Half of 4 is 2. And 2 plus 1.5 is 3.5. So when x equals 2, we're up here at 3.5. Right here. Okay, somewhere right in there. Okay? If we did the other one, it would be, well, let's do it. Okay? When x equals 1, this will be 1/2. Okay, I should have done that. X equals 1, that will be 1/2 plus 3 halves is 4 halves, which is 2. Okay, so right there we are. 1, 2, buckle my shoe. Okay, never mind. Okay, when you go to x equal what we did, 1, 2, 3. When x equals 3, this will be 9, right? 9 halves plus 3 halves is 12 halves, which is 6. 1, 2, 3, 4, 5, 6. There we are right there. Okay? Then when x equals 4, 4 squared is, half of 16 is 8, plus 1.5 would be 9.5. 1, 2, 3, 4, 5, 6, 7, 8, 9.5. Right over here, approximately. Let's see if we can get one more in. X equals 5. 5 squared is 25. Half of 25 is 25 halves, right? Plus 3 halves is 28 halves. 28 halves is 14. Okay. So when you're 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's somewhere up there. Okay? Somewhere up there. What do we have here? We have half of a parabola, right? The other half would be over here, but we don't go over there because x for this thing is always greater than 0. Okay. Now, pretend this marker is red. Okay? 0, 0, 1, 1, 2, 2, 3, 3. What you have here is the identity function. Usually we do it as a dotted line. There's your identity function, and you see these reflect across the identity function. That's what they show in the book. Not quite as pretty as mine, but close to it. Okay? And that's what they're showing here. Here is our original function, square root of 2x minus 3, and then here's the inverse function right here, and that's a half a parabola, and there's your identity function. Sure enough, they reflect across. All right. You don't have to do that, but it's a good, especially for simple functions, it's a pretty good check. This is not what I consider a simple function, but it's not bad. It works for the, leave it, huh? You want to do the checkpoint? Okay, I was hoping you were going to do the checkpoint. Okay, let's do it. Let me see if I can get my, for people at home, they couldn't see me hold the book up, or even this graph, because all they see is this circle doing that. I've got to somehow get that to end before I do the checkpoint. So, oh man, let me try this again. Let me try restarting the program. I don't know which program they're doing. PowerPoint, I guess it is. I'm sorry, this PowerPoint's such a pain in the neck sometimes. The only thing they let us use. There's some better packages out there. Okay, let's go back here. Oh, PowerPoint is restarting. I probably shouldn't have done that. Now I probably confused it again. Okay. Come on. Okay, there we go. Okay. Okay. This is where we, now I've got to get my pen back. Okay. So let's do the checkpoint. F of x is equal to the cube root of 10 plus x. Okay? Now, what's the first thing we got to do? Say again? Graph it. Unfortunately, you're right. Okay, boo hiss. Okay, so let's do our axes here. Now notice I'm putting them in the middle of the page because this is a cube root, not a square root. So you can have plus and minus. Okay? Now, if you remember, hope you remember, we could do our, what you call those, parent functions. Okay? Any questions? Other questions? Other questions? Okay. Now, the cube root function, I don't know if you remember this or not. Remember, the cubic function looks something like this. Remember, that's x cubed. The cube root function is going to be the inverse of that, which is going to be something that looks like that, right? So I'm going to take this one off of there. Okay, that's the cube root function. Okay, cube root, okay. So what we've got here is adding 10 to x, which moves it which way? Okay. Okay. I'm doing backwards from you, so I cheated you there. To the left. Okay, yeah. Okay. It goes 10 spaces this way. Okay. Now this is kind of bad news. Because I don't have enough room, so I'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to be where the cube root function goes from. Oop, that's pretty ugly. Something like that. So this is our function. And all this is just to see if we're one-to-one. What do you think? Do you think this one is one-to-one? Just taking a look at it. Yes, it is. Okay? It is one-to-one. That's the only reason we're going to draw the function anyway, to see if it's one-to-one. And the cube root function, most of the time, is one-to-one. Okay? So we've done that part, so let's erase this. The whole reason we did it was just to determine if it's one-to-one. We did. It was. Okay? So what's our next step? Say again? A little louder? Yeah, make it y instead of f of x. So y is equal to the cube root of 10 plus x. Next. Say again? Switch them, and what does that give us? X is equal to the cube root of 10 plus y. Now what do we do? Solve for y. What's the first thing we better do? Get rid of the cube root, and how would it do that? Do what to both sides? Cube it both sides. So what does that give us? X cubed is equal to 10 plus y. Hey, this is pretty easy. Now what? Solve for y. Subtract 10 from both sides. Okay? And this gives us y is equal to x cubed minus 10. And what is that? Next step? That's your F inverse. Is equal to x cubed minus 10. Okay? Now, what we should do next is take F of F inverse and F inverse of F. Do both of those. They will give you x. Okay? Then, if you wanted to graph it, we already graphed the other one that looked like this. This now will be a cubic function, which is down here, and it will go like this. It goes through minus 10. And those are mirror images of each other across the thing. So yeah. Got it? Now we're skipping some steps here, but you see how it works. Okay, good deal. What's that? And check it. Yeah. You don't have to graph it unless it says graph. I don't think I'll ever tell you to graph those. But you will have some graphing to do, but it won't be one of these. That finishes 1.9, which finishes what we're going to do here, except for vocabulary. So let's do the vocabulary. If f of g of x and g of f of x both equal x, then the function g is the blank function of function f. If f of g of x and g of f of x both equal x, then the function g is the blank function of the function f. What's the title of this section? Section, top of the right-hand page. Say again? Inverse. It's the inverse function of f. Okay? Number 2, the inverse function of f is denoted by, what's the symbol we use for inverse function? F with the -1, superscript -1. Look at the line right below that blank and you see it right there. You see it? Okay. So there's how we denote it. Number 3, the domain of f is the blank of f inverse. The domain of f is the blank of f inverse. This is your terminology, folks. You don't remember us doing domain and range, okay, is the range of f inverse, and the blank of f inverse is the range of f. Domain, excellent. Number 4, this is like pulling teeth, isn't it? Okay. The the graphs of f and f inverse are reflections of each other in the line. What's the line? Often called the identity function. What is that line? What's the equation for that line? This goes back to your parent functions. Remember, I said 0, 0, 1, 1, 2, 2, 3, 3. What can you say about that? This, how it x related to y? 1, 1, 2, 2, 3, 3, 4, 4. They're equal to each other. Y is equal to x. That's the identity function. Okay, I think this is going to be tough to... Never mind, okay. All right. Number 5. The function f is blank when each value of the dependent variable corresponds to exactly one value of the independent variable. Each means how many? You use the adjective each. How many are you talking about? And exactly corresponds to exactly one value. It's said to be what did you say? Someone said it, please? 1 to 1. A function f is 1 to 1 when each value of the dependent variable corresponds to exactly one value of the independent variable. 1 to 1. Okay. That's what that was supposed to be. Number 6. A graphical test for the existence of an inverse function of f is the blank line test. Horizontal line test, we got one right off the bat. Okay. Homework exercises here would include any of the odds, 7 through 13. They're all at Calc Chat. 9's at Calc View. 15 or 17, they're both at Calc Chat. 15's at Calc View. 19's at Calc Chat. Any of the odds, 21 to 31, they're all at Calc Chat. 23's at Calc View. 33's at Calc Chat. 35's at Calc Chat. 37 and 39 are at Calc Chat. 41 or 43 are at Calc Chat, but 41's at Calc View. Any of the odds 45 to 53, they're all at Calc Chat. 45's at Calc View. Any of the odds 55 to 69, they're all at Calc Chat. 61's at Calc View. And then, these are some interesting ones. We didn't have examples in the book, so see if you can get them. 71 through 77, they're all at Calc Chat. And then some others we didn't do, but you should be able to work these out. 79 to 83, they should all be at Calc Chat. If you can't get them, look at Calc Chat. It should have them. Same thing with 85 and 87. They should be at Calc Chat. Okay, then there's one applied problem, 89. That should be at Calc Chat. There's one true false, 91. It should be at Calc Chat. And then there's creating a table, 93 should be at Calc Chat. There's two proofs, 95 or 97, one proof, 95. You could think about doing 97 or 99 if you want to. And then there's one-to-one representation is 101. That should be at Calc Chat as well. 110 is a good section, but we're just not going to do it, okay? You can read through it if you think you might need it somewhere in your future. It's a very nice section, but it wasn't in the course description, so I left it out. We need to move on. All right. There is a chapter summary. Now remember, we didn't do sections 1, 2, and 3. We started at section 1.4. So 1.4, 5, 6, 7, 8, and 9 are the ones you're responsible for. This may be a really good place to build your formula and equation sheet. It has a lot of formulas and equations on it, so you may want to use that. That's up to you. Then the review exercises, again, we didn't do 1.1, 2, or 3. We started at 1.4, which is on page 107, and these odd number exercises are at Calc Chat. If you need more to practice on, 43 or 45 are both at Calc Chat, 47 is at Calc Chat, 49 is at Calc Chat, 51 is at Calc Chat, 53 is at Calc Chat. Then in 1.5, 55 is at Calc Chat, 57 is at Calc Chat, 59 is at Calc Chat, 61, 63, and 65. In 1.6, 67, 69, and that's all they got in 1.6. 1.7, any of the odds 71 to 79. They're all at Calc Chat. 1.8, 81, 83, and 85 are at Calc Chat. In 1.9, 87, 89, 91, and 93 are at Calc Chat. Then you have the chapter test. And again, the odd numbers are at Calc Chat. I think all the answers are in the back of the book, but only the odd numbers are at Calc Chat. And there you have tutorial help and worked out solutions. So where we began would be question number 10, though that's an even question. So if you're only doing odds, 11, 13 or 15, no, 13 and 15, 17, 19, 21, or 23. Okay? And then you don't need to do the rest of it. Okay. That finishes everything we're going to do in chapter 1. Any questions? The test will be Thursday. Tuesday, I'll answer any questions you have. I'll answer any questions you have right now. Do you have any questions on chapter 1? Okay. Then we've still got 4 minutes to go, so let's get started on 2.1. Okay. 2.1 will go much more quickly than, chapter 2 will go much more quickly than chapter 1. It's review material, a lot of it, okay? And so everything we do here is probably going to help you get ready for the test there too. So let's go from current slide. I don't know why this looks so weird, but it is. Come on, there we go. Chapter 2 is polynomial and rational functions, okay? There's 6 sections here. 2.1 through 2.5 are all the polynomial functions, and 2.6 is the rational functions. Now we're going to do most of those early ones, but a lot about the middle there, we're just going to sort of skim through those because they are dealing with it. In fact, I'll show you now. We're going to do 2.1, 2.2, and 2.3 in gory detail. And then 2.4, we're just going to go through a PowerPoint show, okay? Then we'll do 2.5 as much as we can, and then 2.6. They have a section 2.7 that wasn't in our course description, so we're going to skip it. So 2.1 is, guess what? Quadratic functions and models. Hey, we've been doing quadratic functions. So this is a review of what we've already been doing, okay? But we're going to go into them in a little more detail. Okay? How are we doing on time? 2 minutes? Huh? 43? 2 minutes, okay? Our objectives here are to first analyze the graph of quadratic functions. That's going to be pretty easy. We know what they look like, right? We'll write quadratic functions in standard form. You may think, haven't we been doing that? No, we haven't. Okay, we will learn how to do that. We'll use those results to sketch graphs of functions much more easily than plug and chug. And we'll find minimum and maximum values for quadratic functions in real-life applications. We'll find an easy way to do that as well. Okay? So, let's first look at the graph of a quadratic function. Now, this is all review here. In this section, we'll study the graphs of quadratic functions. You are introduced to the following basic functions. What's that first function called? A linear function. That one. A constant function. That one's called the squaring function. You read my hand? No, okay. Now, these two are linear. This is a quadratic function. These functions are all examples of what we call polynomial functions. What does polynomial mean? Poly usually means many. Nomial, I think, comes from the same word as name or noun or something like that. We're going to use it in math speak as terms, many terms. But we allow it to be as few as one. One term here, two terms there. A term is any combination of numbers, variables, multiplied or divided, not added or subtracted. That makes a term. When you have a plus or minus sign in between, that makes more than one term. Okay? The terms are separated by plus or minus sign. This is a two-term polynomial, a one-term, and a one-term. We call this a binomial, a monomial, and a monomial. Those are just other names for it, saying how many is your poly. Okay? So, how are we doing? Time's up? Okay, we'll begin next time with this definition of a polynomial function. This will be Tuesday after I've answered all the questions you have and you've turned in all your quizzes, which I see some coming in right now. That's great. You can stay for it. Okay? Okay. Okay. Uh-huh. Yeah. Okay. Okay, you've turned in your quiz already? Okay, good. Well, Thursday, just be ready for the test. Because I'm only going to be here 30 minutes on Tuesday. I'll be here an hour, but from 8:30 to 9 is the only time I'll be here because I have to leave for my appointment at 9. I'm sorry, yeah. Yeah. Right. Yeah. Are you watching YouTube? Okay, good. That will catch you up. I'll record on Tuesday also, but it's going to be very short. Yeah. Right. No, I'm sorry. I knew that. Hi. What you say? Okay. I believe that was supposed to be 8 minus 8 plus 6. That would have given you minus 2. I think the X is just not right. Okay. I didn't follow you. I didn't have time to check that.
Okay.
Okay?
Thank you.
Uh-huh. gracious. Too many movies. Oh, I've got to end this.